A power series is a series in this form: c0 plus c1 x to the first plus c2 x squared plus c3 x to the third. And c is a coefficient, x is a variable, and n, of course, denotes which term we're talking about in the series. It can also be written like this: cn x minus a, and it's basically the same thing as if we have an x minus a, which is being raised to the power. But the whole point of this is we are introducing a variable into series now. And what we're going to be looking for in these type of problems are values of x that will cause this series to converge. Sometimes it will be all values of x, sometimes it will only be a certain set of x's that will cause a series to converge. And it's important to remember that when a series converges, it has a definite value. When it does not converge, it has an infinite area, so it has no value, or no precise value. But if it has a precise value, the whole point of it is that we can then treat this series like a function, because a function is 1x to 1y. So in order for it to be a function, the x value that we input must have only one y value. If the series does not converge, then it has no definite area, it has no particular y value, so we can't treat it like a function. But if it does converge, then we can treat it like a function. And this has all kinds of applications as we go along in differential equations and further in calculus and physics and all kinds of applied sciences. This will be used very regularly. So let's have, a quick example, because that's basically the whole concept of this. It's just a power series. With a power series, what we're going to be thinking about is what values of x will be allowed for this to converge. So we'll just look at an example and we'll see what we're looking for here. Which one did I pick? It was... No, it wasn't that one. Oh, yeah. Okay. So the first thing I need to do is take the limit, use the roots test, take the limit, so I can have a look at what the common ratio is as n goes to infinity. And once I find out what that ratio is, I'm going to have a look at what values of x will have that ratio be less than 1. So I need this. So this will be n x minus 3 to the n. So this will cancel. Well, this will at least lead to the power 1. So we'll have absolute value sign. And I can pull this out. So I will be left with the absolute value of x minus 3 as the limit. That's a ridiculous L. Can't have that. Goes to infinity. N over n plus 1 I just divide out by n. So that'll be 1 over 1 plus 1 over n. This goes, well, this goes to 0, which makes this whole thing go to 1. So I'm left with the ratio, absolute value of x minus 3. So this is the common ratio, and in order for it to converge, the ratio must be less than 1. Since this is an absolute value, it will be like this. Since it can be plus or minus 1, and add to both sides. So it will converge for values between 2 and 4. And before I finish that, I'm going to test the actual values at 2 and 4. So I basically go back to this equation and I substitute in. I'll do 2 first. So this will be the sum, and I'm just putting in 2 here. So this will mean it will be minus 1 over n, or to the n over n. And this is an alternating series which is convergent. So that means I can put this under here, greater than, or at 2, it's also convergent. If I put 4 in for here, I will have a positive 1, which will give me this. And this is divergent. So I'll leave that there. And now I have the values of x that will cause the series here to be convergent. It is 2, including 2, to 4. These are the values that will cause the series to converge. And I can therefore use these values of x as a function.